There you are, Joan. Something you haven't got the brains to see. A photo, fake as your fanny, Joan. The photo, as I displayed in my last video, is 100% impossible, you stupid idiot. You cannot have a dark subsoil on the moon without a presence of water, idiot. And there is no water on the moon. The photo there is 100% impossible, stupid.
From late 2013 to early 2014, a NASA mission called LADEE explored the moon's tenuous atmosphere and its dust environment. Now, LADEE's observations have led to a new discovery. The lunar surface is periodically releasing water.
What we discovered is that the surface releases its water when the moon is bombarded by micrometeoroids. This is especially noticeable during meteor showers. What we also found is that the surface that's releasing the water is being protected by a layer of few centimeters of dry soil that can only be breached by large micrometeoroids. When the micrometeoroids impact the surface of the moon, most of the material in the crater is vaporized. There is also a shock wave that propagates outward. That shock wave carries enough energy to release the water that's coating the grains of the soil. Most of that water will get released into space, and that's the signature that LADEE detects with its instrument from its orbit. By analyzing the data returned by the neutral mass spectrometer, we found that the intensity and the frequencies of the fluctuations of signals from the water to be perfectly correlated with known meteor streams. For example, we were able to detect a big spike of water during the Geminid meteor shower that occurred in December of 2013.
Thanks to LADI, we now know that trace amounts of water are widely distributed across the lunar surface. This discovery provides a potential resource for future exploration, and it improves our understanding of the Moon's geologic past and its continued evolution.
Since the 1960s, scientists have suspected that frozen water could survive in permanently shadowed craters at the Moon's poles. Both hydrogen and oxygen could be trapped within the lunar soil. So to find water on the Moon, scientists are looking for indications of hydrogen using the Lunar Reconnaissance Orbiter's LEND neutron detector. By observing the interaction of neutrons with the lunar soil, scientists can interpret how much hydrogen is likely to be present. In order to make a detailed interpretation, however, LEND needs to observe a large number of neutrons. Because LRO is constantly moving, LEND is never over one place long enough to count many neutrons. So, to make a detailed interpretation of neutron flux, scientists add together many measurements from many orbits. With each orbit, LEND's dataset gets larger, and its picture of neutron flux continually improves over time. The dark blue regions in this visualization are places on the south pole of the Moon with a suppressed flux of neutrons because of their interaction with hydrogen. These areas strongly suggest the presence of water frozen within the soil. While previous lunar missions have observed indications of hydrogen at the Moon's south pole, the LEND measurements for the first time pinpoint where hydrogen, and thus water, is likely to exist. By combining years of LEND data, scientists see accumulating evidence that there is water on the Moon. And as LRO continues to return data, our picture of the Moon and its water will continue to get better in the years ahead.